Hey, good morning, guys. Or good afternoon. Good evening if you're watching this at the middle of the night. Today we're going to go over our last topic of the year. It's going to be a jam packed, actually, lesson today. There's going to be a lot of different topics I'm going to be covering. Today we're going to be covering standard deviation. We're going to be covering the z-score, the empirical rule, and the bell curve. Okay, there's four big things that you will need in next year. So I'll go over about how to actually calculate the standard deviation, and then from there I'll go over to the bell curve, the z-score, and the empirical rule. All right. Now, standard deviation is different ways for us to, calculate a spread of data. So, for example, it would be like, well, how many people are taller than 6'5"? How many people are shorter than 5'10"? Things of that nature. Like, what is your average person have in their fridge via fruits or vegetables or whatever the case is, right? Standard deviation will help us understand how to calculate those things. So with every different set of samples we have a mean, and then from that mean we can actually calculate the standard deviation. All right. So I have drawn 5 wonderful people here. All right, and as you can see, there's numbers under each person. Now, let's just say each person likes sweet tea. All right, I love sweet tea, so I'm hoping you guys do too. So sweet tea, we have sweet tea. Every different person has a different amounts of gallon of sweet tea in their fridge. All right, now with this being said, we have person 1 has 2, person 2 has 3, person 3 has 9, person 4 has 10, and person 6 has 16. All right, and I want to calculate what is the standard deviation of the average amount of sweet tea that each person has in their fridge. All right, the first thing we're gonna have to calculate is the mean, right? Step 1, you want to calculate the mean. Okay, calculate the mean. Now the mean is also understood as x bar. X bar is the mean. So that is another understanding of what the mean is represented as x bar. Sorry about that, guys. And the second thing you want to do, once you figure out your x bar, you want to subtract the mean from each data point that's given. All right, so that means you're going to calculate, it's going to look like this, x minus x bar. That is your next thing to do. All right, the next thing you're going to do is you're going to go ahead and then you're going to square each difference. So you're going to take whatever you get here, x minus x bar. All right, you're going to square that. Okay, then you're going to divide by that the difference, or the number of data points that you have, and then so 4 you're going to divide by number of n, we call n number of data points, right? Number of data points. Okay, and then step 5. Okay, you're gonna go ahead and square root that final. So you're gonna square root. All right, you're gonna square root that final number. Okay, and that'll give you your standard deviation. Okay, now this is the 5 steps to actually calculate it, and this is the formula that's given in order to solve your standard deviation. The formula looks like this. Sigma, right, is written as sigma, all right, lowercase sigma they say, right, and it's gonna look like this. It's a big old square root, and then you're gonna get capital sigma. It looks like that, and then you're gonna get x minus x bar squared, and then divide that by n, right? So like I said, all right, this is what everything understands. So sigma equals your standard deviation, SD, right? And then that's lowercase sigma. So then capital sigma, all right, equals the sum of that, the sum of each, okay? Okay? Meaning the sum of this entire thing here. Okay? X equals your data points. Okay? And then x bar equals your mean. And then you have n, which is your number of data points, right? Okay, these are all many different things that'll help you understand in calculating your standard deviation. So I wrote down the steps here for you. This is the actual meaning of the function itself, like the function itself, and these are the different understanding of each different variable that you have there. All right, now I'm gonna go ahead and give you an example based off the amount of people that we have drinking sweet tea. All right, y'all, so the first thing we're going to go ahead and do, we're gonna go ahead and understand how to calculate this function here. All right, now, the first thing we know is that each different person has a certain amount of sweet tea in their fridge, all right? So we're going to go ahead and try to find X bar first. So X bar, all right? We're gonna add each of this up and then divide by the amount of people that's given here, all right? So what you're gonna go ahead, you're gonna get 2 plus 3 plus 9 plus 10 plus 16. You're gonna divide that by 5. Now 2 plus 3 is 5, 5 and 9 is 14, 14 and 10 is 24, 24 and 20 and 16 is 40. All right, so this here, you're gonna get 40 over 5, which reduces to 8. So we know that your X bar equals 8. Okay, X bar equals 8. The next one we're gonna actually have to do is we're gonna go ahead and draw a table. And you're gonna draw it by your X value, your X bar value, your X minus X bar value, okay? And then you're gonna get X minus X bar squared, okay? These are many different tables you can draw. And now, like I said, it could be easier if you just plug it into the value. I'm just doing it step by step for you guys to understand it, all right? So we're going to get 2, 3, 9, 10, and 16, okay? Okay, so now we have X bar is 8 across the board, okay? Now, you're gonna take X minus X bar. So this is X bar. 2 minus 8 is negative 6. 3 minus 8 is negative 5. 9 minus 8 is 1. 10 minus 8 is 2. 16 minus 8 is 8. Okay? Now, you're going to go ahead and square these numbers here. That's here. So you're saying this here. Now you're going to go ahead and square those numbers because it's going to get rid of any negative values here. So this becomes 36. Okay? This becomes 25. This becomes 1. This becomes 4. And this becomes 64. All right? Now, the next thing you're going to do, you're going to take all of this here and you're going to add it together, then divide by, remember, your number of data points. Now, your number of data points is here, is 5. 5 is the number of data points that you have. This is an individual set of data points. Now, the total collective here is 5. All right? So now what you're going to do, you're going to take 36 plus 25 plus 1 plus 4 plus 64. I think that should give you 130, I believe. Yes, 130. All right, so you're going to take 130. You're going to divide that by 5 now. All right, so you can see the sum of everything that's here. So the sum of everything that was here, right? Does that make sense? So it's going to look like this. Standard deviation, 130 divided by square root of 130 divided by 5, right? So you're going to take 130, you divide that by 5, okay? You get 26, and then you're going to take the square root of 26. So it should give you 5.09 or 5.1. So this would equal 5.09, or you can approximate that to 5.1. So the average person who has sweet tea in their fridge, the average amount of sweet tea each person has in their fridge is 5.1 with a mean of 8. They have a mean of 8, right? But the standard deviation of average units that they have in their fridge would be 5.1. All right, now I can go over a different example with you guys and solve that for you shortly.
This message is brought to you by Mr. R's Algebra 2 class. If you did miss episodes of The Last Dance, you can always catch them back on ESPN and Netflix. If you have an issue with me saying that Michael Jordan is the greatest basketball player of all times, I don't care. You can at me. It really won't make a difference. We all know he's the best. And don't you even mention the blasphemy of LeBron James being better than Michael Jordan. Because if you do, I will fail you on the final.
All right, y'all. Now what we're going to do, we're going to go ahead and maybe look at it at a different way. Now, there's a different formula when it comes to this. There's a different formula, or there's an added component to this formula when you're only taking the sample size of a population. All right? So what we're going to do here, we're going to take a sample size of the population of those who buy groceries or spend or have money in their wallet. Let's go with that. Those who has money in their wallet, right? And we're just going to take a sample of 5 people out of the population. Now, each person has, let's say person 1 has $21. You have $50 here. You have $62 here. You have $82 here, or $85 here, and you have $90 here. All right. So this is 85. Okay. This here is 62. All right. All right, so we have 5 different people representing the population. This is our sample size. All right, so what we're going to do here, we're just going to go ahead and do the same steps that we've done before, and we may change it towards the end just a little bit because it's a little bit different. We're taking a sample size of the population, so it's not all of the population, so we do have to adjust the formula a little bit, and I'll show you guys towards the end. All right, so the first thing we're going to go ahead and do, and so we're going to go ahead and find the mean, or x bar, right? Mean is our x bar, and our x bar equals what? All of these numbers here divided by how many people that are given, all right? In the sample size, right? So we have 21 plus 50 plus 62 plus 85 plus 90. We're going to divide that by 5, all right? So if you plug that into your calculator, you should get, sorry, I'm doing it right now for you guys. You should get 308, so you're going to get 308. You divide that by 5. Now, when you divide that by 5, you should get $61.60, right? So the mean amount of money, or the average amount of money that somebody has in their wallet, is $61.60. So just make a note of that. So now we're going to say x bar, x minus x bar, and then x minus x bar squared. Okay? We have that. So we're going to get 21, 50, 62, 85, 90. Okay? So we're going to get all these different points here. So x bar was 61.6, 61.6, 61.6, 61.6, 61.6. All right? Now, 21 minus 61.6, all right? You're going to get negative 40.6, okay? 50 minus 61.6 is negative 11.6. 62 minus 61.6 is actually 0.4, okay? And then 85 minus 61.6, I believe, is 23.4, okay? And then 90 minus 61.6, I think that's 28.4. 28.4. All right. Now, what you're gonna do, you're gonna go ahead and square all these numbers. All right. We're gonna square all these numbers. So 40.6 times 40.6, or negative 40.6 times negative 40.6, is 1,648.36. Okay. Negative 11.6 times negative 11.6, you're gonna get 134.56. All right. Now 0.4 times 0.4, you're gonna get 0.16. Okay. And then you're gonna get 23.4 times 23.4. You should get 547.56. Okay. And then 28.4 times 28.4, you're gonna get 806.56. 806.56. All right. Now we're gonna go ahead and add all these up. So the sum, right? So now it's gonna look like this. So you're gonna get the standard deviation equals the square root of the sum of everything here. So the sum of everything that you got from here, right? So when you add everything up together, right? You add everything up together, you're gonna get 3,137.2, all right? 3,137.2. So we get 3,137.2. Sorry for the knocking. I don't know what that is. And then you're gonna divide that by the number of people that you have. Now, mind you, remember I told you the formula does change, okay, when you have a sample set of the population. So when that happens, whenever this happens, when you have a sample set of the population, a sample set, right? Now our sample set is only 5. So you're gonna take n and then minus that by 1, all right? So now we have 5 minus 1 in this case. So 5 minus 1 is 4, okay? So what you're gonna do, you're gonna divide that by 4. So 3,137, divide that by 4. All right, you guys should now get 784.3. All right, now you take the square root of that. All right, now the square root, okay, the square root now is going to equal, take the square root here, right? So the square root now you have equals 28.005. Okay, now if you want, you can go ahead and round that up to the nearest hundredth, you could say. All right, and if you want to approximate it, it would be 28.01. Okay, so each one of these will work, but most likely they'll probably take the approximation number value, unless they say not to. or unless it's just an even number just like this and it doesn't do anything. So what you're going to get here in our example here that we said the sample amount of people who have money in their wallet, all right? Our mean was 61.6. That's the mean, that's the average, but the average unit of what each person has in their wallet is $28.01. That is the average amount. All right, and now we're going to go ahead and go into the bell curve, z-score, and the empirical rule.
What's good? Yo, dog, understand me, say? Understand me, attack.